Hey guys, welcome back to chapter 13. We are going to finally get into our last section of this chapter. And it has to do with messing with equilibrium, right? So far we have put some chemicals together. We've allowed the reaction to get to equilibrium, and then we've kind of mathed some information through it. What we're going to do today is what happens if we mess up that equilibrium? What happens if we change something? What changes? So it will establish a new equilibrium, but that equilibrium will look a little bit different. So the principle that we're going to talk about here is something called LeChatelier's principle. So when a chemical system is at equilibrium and it's disturbed, the system will shift in a direction to minimize that disturbance. So we stress out our equilibrium. It's going to react to alleviate that stress, just like we would in real life, right? Something's stressing me out. I'm going to do something to alleviate that stress and find a new equilibrium, find a new happy place. So reactions are not much different than us. A system at equilibrium under stress will shift to relieve that stress. So there's two sides to a chemical reaction. There's reactants and there's products. One of those sides is going to feel the stress. To relieve that stress, it's going to push the other way. There will be a change in the rate of the forward or the rate of the reverse, to return that system to equilibrium. So here's how we're going to discuss this. If you were in a face-to-face class, I would be using my hands as a balance. But here's kind of what this is going to look like. So equilibrium is going to look something like this. Okay? I know equilibrium does not mean everything's balanced. We could have more reactants. We could have more products. It's not an exact perfect scenario. But let's pretend like equilibrium means our balance is level. There's going to be a stress to some side of our level. So if there's a stress, let's say to the product side, our balance will then look like this. It's pushing down or weighing down on the product side. What we are going to talk about is when this system is under stress, when this balance is not level, when it's tilting one way or the other, which way are we going to have to push? What are we going to have to do to balance it out? And in this case, we would have to make more reactants so that we get back to that balance. Okay. So that's what we're going to talk about in this section is stressing one side or the other, that balance isn't level anymore, and what do we need to do to level that balance out? There's going to be two types of stresses that we talk about. The first is going to be affecting the concentration. So we're going to change the concentration. We're going to add more reactant or add more product. We're going to take away reactant or take away product. So we're going to change the concentration that we find at equilibrium. The second type that we're going to talk about is the temperature change. So if we heat it up, what happens? If we cool it down, what happens? So we're going to talk about two different types of changes. So affecting the concentration. There's a number of different things that we can do. So the four scenarios that we're going to talk about is adding a reactant, adding a product, removing a reactant, removing a product. So those are going to be the four different scenarios that we talk about. So let's get started. So here's our first chemical equation. So we've got N2O4 will react to make 2 molecules of NO2. Okay. So we are at equilibrium. This is at equilibrium. Balance is the same. The first stress that we are going to do is we are going to add N2O4. We're going to add more to the reactant side. If I add more to the reactant side, so I'm going to put some chemicals on this side, that's going to cause the reactant side to be heavy. Going to cause the product side to feel lighter. So we are out of balance. We're out of whack. If we want to get back to balanced, okay, so we want to get back to our equilibrium. Which way is this reaction going to have to push to get back to equilibrium? Well, we're going to have to push towards the product side. We're going to have to use some of the reactants to make more of the products. So how do we get back to equilibrium? We're going to make more product. So balanced at equilibrium, we add some of our reactant, so we stress out the reactant side. That side gets heavy. Now to get back to balance, the reaction's gonna push towards the products. We're gonna make more products. That'll push that side of the balance down, and we'll be back to equilibrium. So the effect of adding reactants will shift the equilibrium towards the product. We have to make more products. Talk about another addition. So equilibrium. Oh no. Green is back to equilibrium. Try to keep the same colors. So, in this case, we're adding a product. All right, so in this scenario, we're adding a product. So this is the product side. We're adding more of our product to this system. That's going to cause the product side of our balance to feel heavy or to go down. So this is where we are all out of whack, right? We're not balanced. So which way is this reaction going? Which way is this reaction going to have to push to find equilibrium, to find that balance again? So it's going to have to push back towards the reactants. So to find equilibrium, to get back to equilibrium, we're going to have to make more reactants. So to alleviate this side, we push back towards our reactants. So the effect of adding a product shifts the equilibrium back towards our reactants. Next scenario. Let me get our balances drawn on the bottom. All right, I got our balances drawn on the bottom. So again, we are at equilibrium to begin. This time the stress that we're going to apply is removing our reactants. So in this case, we are taking some of the reactant away. So what that's going to cause is our reactant side is going to feel lighter. Our product side is going to feel heavier. So if I were to animate this over here, let's say at equilibrium, we had 3 stones on each side. And in the act of removing reactants, I removed 2 of the stones. This side is going to be lighter, and this side is going to be heavier. Okay? So the act of removing the reactant causes the product to feel heavy. So what are we going to have to do to alleviate this stress? We have to make more of our reactant. It's going to push back towards the reactants. So to get back to equilibrium, we make more reactant. So the effect of removing reactants will shift the equilibrium back towards the reactants. Let's take a look at what happens if we remove the product. Let me get our balances here. All right, we've got our balances on the paper. So in this scenario, we are removing our product. So again, if we had 3 stones on each side of our scale, in this case, we are going to remove the product. So removing the product is going to make the product side feel lighter, and it's going to make the reactant side feel heavier. So by removing the product, we stress out the reactant side. So which way are we going to have to push to alleviate that stress? We're going to have to make more of our product. It's going to push towards the product. So to get back to equilibrium, we make more product. So the effect of removing the product will shift the equilibrium towards the products. So that was the effect of adding and subtracting concentrations, right? So if we add some more, we increase concentration. If we remove, we decrease concentration. And that's going to throw our balance off. That's going to cause one side to feel heavy and one side to feel lighter. If you can understand that, if you understand this, like this side stressed out, that side stressed out, the second manipulation that we talk about is temperature. It's very, very similar to this. So now we're going to talk about the effects of temperature on a chemical reaction. Okay. So here's our chemical reaction. We're at nitrogen reacts with hydrogen to produce ammonia or NH3. Okay, so this is our chemical reaction. The one piece of information that we need to know if we're going to determine the effects of temperature is we need to know if it's an endothermic or exothermic reaction. Okay. In this case, this reaction is an exothermic reaction. Exothermic reaction means heat is exiting the system. So if we think about heat exiting the system, we can also think about heat as being a product. It's given off or produced during this chemical equation. So that connection right there, exothermic, heat is exiting the system, we can treat it kind of like a product. Now when we think about heating it up and cooling it down, now we can think of it as adding a product or removing a product. It's the same thing that we talked about before. So let's take a look at what this looks like. Let's say we increase the temperatures. That's what you see up here at the top, temperature increase. So we've got our balance. We're at equilibrium, we've got our balance. And in this case, we're increasing the temperature. So increasing the temperature would be like adding a product. So if I add heat, I'm adding more to the product side, and the products are going to get stressed out. They're going to feel heavier. If heat is a product and we're adding more heat, that's going to stress the product side. So to get back to equilibrium, we are going to push towards the reactants, or we are going to make more reactants. The effect of adding heat pushes the reaction towards the reactants. Same scenario, still an exothermic reaction. Heat is still a product, but now we are decreasing the temperature. So up here, a decrease. So if we are at equilibrium here, the act of decreasing the temperature means that we are essentially removing a product. So if we're decreasing the temperature, we're removing or taking away that heat. So the act of removing a product is going to make the product feel light, and it means the reactant is going to feel heavy, right? We remove some stones here. That part is going to go up in the air. For an exothermic reaction, is going to stress out the reactants. So to alleviate that stress, this reaction is going to push towards the products. So decreasing the temperature for an exothermic reaction is going to cause the reaction to push towards the products. Here we've got an endothermic reaction. In an endothermic reaction, heat enters into the system. We have to add heat in order for this reaction to take place. Okay? So in an endothermic reaction where heat is entering the system, we can think of heat as being a reactant. We have to add it to the mix. So now let's think about our different scenarios if heat is in fact a reactant. So up here, we're going to start with a temperature decrease. So here we are at equilibrium. If I decrease the temperature, right, so decreasing the temperature essentially would be like removing a reactant. So decrease temperature, take away heat, take away a reactant. So that's going to cause the reactant side to feel light, and that's going to cause a stress on the product side. So to alleviate the stress caused by adding heat, to relieve the stress caused by taking away heat, it's going to cause the reaction to push back towards the reactant. Remove a reactant, push towards the reactants. All right, still an endothermic reaction. Heat is still a reactant, but now we are going to increase the temperature. So here we are at equilibrium. Temperature increase is like adding a reactant. So increase the heat. So it's going to add more to the reactant side. That's going to cause the reactant side to feel stressed or get heavy. And so to alleviate that stress, this reaction is going to push towards the products. So adding heat to an endothermic reaction is going to cause it to push towards the product side. Okay. That's it for LeChatelier's principle. We take a very qualitative approach. So qualitative is in the absence of numbers. So you're just going to have to think through scenarios. If I say like, this is an endothermic reaction and we add heat, which way is the reaction going to push? You would just need to tell me that it's going to push towards the products. That is also it for chapter 13. So that concludes chapter 13. That's everything that's going to be on the test. I hope you guys found this helpful.